Welcome to Stone Cold Math. This is the first debut lesson with videos that you are going to be able to use to study for your lessons. My recommendation is that you go through the lesson, the video once, look what it says, and then go back and take notes on what you feel is important for your lesson. Today we're talking about classifying angles, lesson 1. Your lesson essential question: how can I classify angles and find angle measures from a drawing? So this is 2 lessons in one. We're packing them in. Next. What makes an angle? Angles are formed when 2 line segments or rays connect at a point called the vertex. So the vertex is where these angles will connect, and the angles are what results in between the sides of the angles. We have different angles. Angles can be right angles, meaning they form a 90-degree perpendicular side, and we indicate that with a square. That means it's a 90-degree angle. We can have acute angles. That means the angles, the sides are less than 90 degrees. So it'll be less than that perfect L. And then we have obtuse angles. The angles are greater than 90 degrees, and they'll be wider than that 90-degree angle. Okay, 4 more types of angles. Angles can be straight angles, meaning the degrees between the 2 sides are 180 degrees. The sides are on one line. The vertex can be anywhere on this line, but that's 180 degrees from side to side. We can have vertical angles, which means the angles are opposite when 2 lines intersect. Here's our vertex. These are vertical angles. These are vertical angles also. I just didn't have the little arcs there. I can have adjacent angles, and those mean the angles share a side. They have a common side, same vertex. These are adjacent angles. They don't have to have the same measure, they just have to have a common side. And congruent angles. Congruent means it has the same measure, so the angles have the same measure. They can or don't have to be adjacent to each other. Naming angles. You can name an angle by its vertex or by its points. This is angle 1 because that's the identifier in the angle, in between the sides. We can name it angle Y based on the point at the vertex. This is angle Y. Or we can name it by the 3 points. 1 point on the side plus the vertex angle plus another point on the side. So I have angle X, Y, Z, but I can also do it in the opposite order, angle Z, Y, X. When I do that, the vertex point always has to be the middle letter. Okay, here's example 1 for you. I have angle PQR, or angle Q, or angle 1, or angle RQP. Name the angle shown, then classify it as acute, right, obtuse, or straight. Kind of gave that one away. So I've given you 3 ways to name it, but can you identify what kind of angle it is based on our definitions of these 4 types of angles? So these are our 3 choices, and since the number is less than 90 degrees, it's an acute angle. And by number, I meant angle measure. Since, not the number 1, nothing to do with it, but since this angle, these sides, are less than 90 degrees apart, it's an acute angle. We can say it's acute angle. Isn't it cute? See what I did there? Okay. Try this. you have this diagram. Name a pair of vertical angles. And remember, vertical angles are going to be angles that are created by two intersecting lines. They are congruent. These are vertical angles. DFE is vertical to AFB. Name a pair of adjacent angles. We have a bunch of adjacent angles here. BFC is adjacent to CFD, which is adjacent to DFE, which is adjacent to EFA, which is also adjacent to AFB. Any two angles that share a side will be adjacent. Find the measure of AFB. This is a little different. We know that a right angle, CFD, is 90 degrees. We know that AFD is a straight angle, and that's 180 degrees, which means CFA has to equal 90 so that this whole thing equals 180. Well, this piece is 50. It has to equal 90. So the measure of angle X would be 40. Here's another example. Overhead view of an intersection. We've labeled this angle 1, angle 2, angle 3, angle 4. This is when it's more appropriate to use numbers than it is to use letters. There's streets. We're not going to put points on the streets. It's easier to label it with numbers. Identify a pair of vertical angles and adjacent angles. Well, vertical, I could say angle 1 is vertical to angle 3. Angle 2 is vertical to angle 4. And adjacent angles mean they just have to share a street. So angle 1 is adjacent to angle 2. Angle 2 is adjacent to angle 3. Angle 3 is adjacent to angle 4. And angle 4 is adjacent to angle 1. Can angles be vertical and adjacent at the same time? I'm going to let you think about that one. Brownie point if you can bring that back to me tomorrow in class. Okay, try this. Same intersection. Identify all the pairs of vertical angles and all the pairs of adjacent angles. I might have given that one away last slide. Find a missing measure. This is the other half of the lesson. This requires math. Here we have this diagram. I have two angle measures. Angle OAC is 48 degrees. Angle TAO is 2x. Since TAO and angle OAC form a straight angle, the sum of the measures equals 180. I need to find the measure of TAO. I can take what I know about straight angles and write an equation. This angle and this angle have to sum to 180 degrees. If I replace the angle names with the measures I have, my equation looks like this. I subtract 48 from both sides, and 2x equals 132. This angle measure, TAO, equals 132 degrees. Some questions will ask you, what does x equal? That's going to require you to take it a step further. And in order to find out what x equals, tell me tomorrow in class, there'll be a brownie point. Finding another missing measure. So now I have this angle, and what should be standing out to you is that this is a special kind of angle we've already talked about because it has that square there. And that should tell you that it equals 90 degrees. So 35 degrees plus 4x plus 7 equals 90 degrees. Since angle SOD is a right angle, the sum of angle SOA and angle AOD will equal 90 degrees. I can rewrite that as an equation with my angles, replace it with my measures, and I can solve for the missing angle. If this is 35 degrees and the whole angle is 90, this piece equals 35. And again, I can take it one step farther and ask you, what does x equal? Have to do a little more math for that. Did I mention it's a brownie point? Okay, so we're going to use what we know about vertical angles and adjacent angles to help you find missing measures. Here's example 3, and this gets a little busy. I have this diagram. One angle is 2x plus 2 degrees. The adjacent angle is 50. Adjacent to that is 130. Adjacent to that is 3y minus 10 degrees. Since 3y minus 10 and 50 degrees are vertical, that makes them congruent. So we can say 3y minus 10 degrees equals 50 degrees. And then we can solve for y. 3y minus 10 equals 50. I add 10 to each side. 3y equals 60 and divide by 3 on each side. Y equals 20. I could have also used adjacent angles and said that 3y minus 10 plus 130 equals 180 degrees, and I could have solved that way as well. I would have come up with the same solution. Try this with the same diagram. Now find the value of x for a brownie point tomorrow. And that concludes our first lesson on classifying angles. I hope you go through and get the notes you need, and I can answer any questions you have in class.